Good morning and welcome to week 3 of our summer math session. All right, so we are at day 1 and we're going to go over week 2's day 3's exit ticket. So here we go. So 4 goes into 33. It goes into, because it can't go into 3, but I don't know how many times it goes into 33. So I'm going to do my 4 times tables. 4, 8, 12, 16, 20, 24, 28, 32, and 36. 32 sounds like a winner right there. So it goes in 8 times. We'll put that 8 above this 3. 8 times 4 equals 32. I subtract to get 1. I bring down the 2. Now I have 12. 4 goes into 12 how many times? 3 times. 3 times 4 equals 12. I subtract, I get nothing left over, giving me the solution of 83. Awesome job. So today and next week we're getting into fractions. But that doesn't mean we're done with multiplication and division because multiplication and division are almost what's called a stepping stone to fractions. Excuse me, sorry about that. So let's get started with our model problem. So I have 1/6. I want to find what makes the fraction equivalent. So I have a numerator of 2. Now remember, numerator is our top number. Denominator is our bottom number. Think denominator down, D and D, right? Denominator down number, okay? So we know the numerator here, but we want to know what the denominator is. So how do we solve this? How do we solve for the missing denominator? So how did I get from 1 to 2 is what I have to ask myself. 1 times what gave me 2? Well, let's do our 1 times tables. 1 times 1 equals 1. 1 times 2 equals 2. Oh, it's 2. 2 got me to 2. So 1 times 2 gave me 2. Whatever you do to the numerator, you have to do to the denominator. So if I times the 1 by 2 to get to 2, I need to times the 6 by 2 to get to my denominator. 6 times 2 is going to give me 12, which means my denominator is 12. Now I have an equivalent fraction of 1/6, which is 2/12. What does that look like? What do you mean they're equivalent? So when I'm talking about equivalent fractions, my best reference to this is think of Bruce Wayne and Batman. They're the same person, aren't they? But when Bruce Wayne puts on that mask and that cape, he looks different. But he's the same person. Same thing here. 1/6, think of it as Bruce Wayne, and 2/12 is Batman. Okay? So, and if you've seen any Batmans, maybe Batman looks different. Depending on which movie or TV show you watch, he might look different. So there could be different looking Batmans, but they're still Bruce Wayne. Okay? So with that being said, let me give you a picture of what this might look like. So here is 1/6 shaded in. How is that 2/12? Well, if I have my denominator of 6 and I shaded in 1, what happens if I make my denominator 12? Meaning, if I break this up into 12s, okay, I'm going to draw another picture. Pretend they're equal. I'm going to break it into 6 first. Now I'm going to split every piece into 2. That's where that 2 comes from. So I'm going to split that one into 2, that one into 2, that into 2, that into 2, and that piece into 2. Now I have a denominator of 12. There's 12 there. 2 of them being shaded in. And they're the same, aren't they? Equivalent. Bruce Wayne meets Batman. Same person. So let's go ahead and actually do some together. I'll have you start it off, and then we'll check to see how you did. So 3 6 equals 9 over what? Go ahead, hit the pause button. I would start off doing your 3 times tables to see how many 3s it took you to get to 9. Hit the pause button now and solve. Okay, so to get to 9, I did my 3 times tables here. 3 times 1 equals 3. Nope, we're looking for 9. 3 times 2 equals 6. 3 times 3 equals 9. Which means it took me 3 times 3 times to get to 9. I need to times the 6 now by 3 to find my denominator. Well, what is 6 times 3? Well, I can do 3 times 4 equals 12. 3 times 5 equals 15. 3 times 6 equaling 18. There you go. There's your denominator. So my denominator will be 18. 9/18. What does that look like as a picture? So if I split this up into 6 again, I have 3 of them shaded in. Now, I'm going to take that picture and I'm going to actually break it into 18 parts. Every part that's partitioned, 1, 2, 3, 4, 5. Oh my goodness, that's not 6. That's 5. So I forgot to do 1. There we go. 1, 2, 3, 4, 5, 6. There we go. 3/16. Every partition spot I need to break into 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All together, I'm going to have 18 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 parts. But 9 of them is what's shaded in. All right? So 18 being the denominator I'm missing. Number 3. 1 over what gives you 2/14? Ooh. Okay, so now I have 1 times what gives me 2. So what's that missing number? And when I find that missing number, okay, how am I going to figure out what this denominator is? See if you can work up through it on your own by hitting the pause button, and then we'll come back over it. So how I got from 1 to 2 is by multiplying by 2, right? Then 1 times 1 equals 1, 1 times 2 equals 2. So I'm going to multiply whatever this number is by 2 to get to 14. But wait a second. I don't know what that number is. I don't know what number times 2 gives me 14. Well, what's the inverse? Right? If we're missing this number here, we need to do the inverse of multiplication to find our missing number, our missing factor. So I'm ultimately going to do 14 divided by 2 to find out what that is. 14 divided by 2 to give you your missing number. When you do that, you get 7. 14 divided by 2 equals 7. How did I know that? Well, I'm going to do my 2 times tables. 2 times 1 equals 2. 2 times 2 equals 3. 2 times 3 equals 6. 2 times 4 equals 8. 2 times 5 equals 10. 2 times 6 equals 12. 2 times 7 equals 14. That's the missing number. So 14 divided by 2, 14 divided by 2, you're going to get 7. The fact family. All right, one more. 3 over what denominator equals 6/10? Go ahead to solve now. Hit the pause button, please. Okay, so first we need to figure out how many times it did take me to get from 3 to 6. Well, 3 times 1 equals 3. 3 times 2 gave me 6. So it's going to take me 2 times to get to 6. Which means I got to figure out this number times 2 gave me 10. How am I going to figure out that number? I'm going to do my 2 times tables over here. 2 times 1 equals 2. And I want to find out 2 times what gives me 10. So 2 times 2 equals 4. 2 times 3 equals 6. 2 times 4 equals 8. 2 times 5 gave me 10. So the missing number is 5, because 5 times 2 will give me 10. So 5 is our denominator that's missing. All right, so with that being said, go ahead and head off to the exit ticket. Great participation today. Really appreciate you guys working through these problems in your packets. And we'll see you back here tomorrow. Bye.